Action.
Hello, my name is Prince Obadiah Daniel Dineko, also known as the mathematical arithmetical biologist. So I'd like us to consider this topic, which is known as forces acting on an inclined plane. But before I start, I urge you to click on the plus button, like my videos, share to others so that they can learn from the video. So what is an inclined plane? An inclined plane is a machine that assists in raising objects up when placed at an angle to the horizontal. Now, whenever a body is placed on an inclined plane, there exists some forces that act on the body that is placed on that inclined plane. So, let us get to work. If this is an inclined plane that is placed at an angle theta to the horizontal, this is the horizontal ground. The horizontal ground. This is the inclined plane. The inclined plane, which can be a plank of the choice. So if you have a body that is placed on this inclined plane, for instance, if you have a cylinder that is filled with gas, a big cylinder, which you want to lift into a vehicle, it will be reasonable for you to place a plank at an angle to the horizontal so as to move the cylinder up the plane. Now, that will make the work easy. So whenever you have a body placed on an inclined plane, the body will actually exert its weight pointing towards the ground. The weight of the object is W, as you can see it here. At the same time, the plank will exert a reaction, an upward force on this body. So we call that upward force normal reaction, high. And at the same time, there is a force which is a component of the weight of this body that will be acting in the same orientation but opposite direction to the reaction, which is this. But we don't know the force. Now, for you to understand this case here, just try to picture a tipper which is ready to offload the sand in it. You would agree with me that a tipper, let me draw a typical tipper for you to understand what I'm trying to present here. Don't mind my diagram though, the knowledge is what matters. So let's say this is a tipper which is about to offload the material in it. You would agree with me that this pan that holds the material is connected to an absorber here. Now this absorber is the object that vertically pushes that pan for it to be able to release the sand in it. As this object is pushing the pan, we can call that the normal reaction. At the same time, this absorber is acting against the body of this vehicle, which enables it to push the pan to the point that the sand will pour off. And that is that force that we have here. And at the same time, this pan is acting, which the body here is acting against the ground due to the pull that the head is actually exerting on it. And that is this W we have here. Now, having established the fact that we have the normal reaction and an opposite force, which is in the same orientation with the normal reaction, we need to obtain the value of this force. Now, how do we obtain the value of this force? We are going to consider, before I proceed with that, there is also a force that has the tendency of pulling this object down. If peradventure there is something wrong with the object moving up. What I'm trying to say in essence is this. For example, if a rope is attached to the cylinder that is filled with gas, and someone is placed on the vehicle drawing that cylinder filled with gas upward with a pulling force P. If something gets wrong with the rope, peradventure the rope gets caught, there is tendency for this object to move downward. And that object will move with a particular force, which we don't know. And right about now we are going to get those two forces. One, the force that is acting vertically opposite to the normal reaction, and also the force that is capable of pulling the object down toward the plane. So let's call this Why? Because it is vertical with comparison to the plane, which is the inclined plane. Now let's connect this to form a triangle. On that note, if you connect this to form a triangle and extend this to this point, then you draw an extension to form a rectangle here, you would agree with me that this line I have actually produced here and this line here are opposite each other. On that note, they must be equal to each other. So let's call this x, which is the horizontal axis, and this is y, the vertical axis. Now, based on similarity of triangle, if you connect this to this, we have a right angle triangle. If you connect, as we have connected this now, we have a right angle triangle here. So based on similarities, we can call this place angle theta. Now, this triangle we have actually generated here will enable us to obtain the force that is capable of sliding this object down this plane, and also the force that is vertically opposite to the normal reaction. So let's extract this triangle to do that very quickly. So if we extract this triangle, we are going to have something like this. We have the weight of the body, we have the horizontal component of the weight, which is x, and the vertical component of the weight, which is what? Y, and we have the angle theta. Now, the angle is facing x. On that note, x is opposite, y is adjacent, and w is hypotenuse. So, considering the x force, which is the horizontal component, we are going to have sine theta, that is opposite over hypotenuse, that is x over w. Now, if you cross multiply to make x subject of formula, we are going to have x will be equal to w sine theta. But we know that w is the weight of the object, which is the product of mass and acceleration due to gravity. On that note, x will be equal to mg sine theta. Which means x here, remember I have established the fact that x is parallel to this line, this force here. On that note, you can say the force that is capable of sliding this object down this plane is mg sine theta. I believe it's clear. Now, we need to obtain this force, which is vertically opposite the normal reaction, and that is y in this case. Now, considering this will be the adjacent, we are going to have cos theta to be equal to y over w. Now, if you cross multiply, we have y to be equal to w cos theta. We know that w is the product of mass times acceleration due to gravity, and that means y will be equal to what? Y will be equal to mg cos theta. So that means here we are going to have mg cos theta. So I will establish this illustration we have on the board. I would like us to consider inclined plane, the forces acting on the body on an inclined plane. Since inclined plane can be in two forms, either rough or smooth. So first of all, let us to consider forces acting on inclined plane, which is what? Which is rough. Which is rough.
Impossible.
So now, remember I have established the fact that inclined plane can either be rough or smooth. So first of all, let's deal with rough inclined plane. Now, when a surface is rough, there exists friction on that surface. So which means that we are going to be considering another force, which is called friction. Now, talking about rough inclined plane, there are two cases we need to consider when it comes to rough inclined plane. And the cases will be applied based on the position of friction when the body is about to move up and when the body is about to slide down the plane. So first of all, remember I said the cases for rough inclined plane are two. So the first one is case one. Case one. That is when the body is about to move up the plane. Move up the plane. What happens? So in this case, we are going to have this kind of diagram. So pay attention to understand this diagram very well. Remember, the body is about to move up the plane. So we are going to have the body like this. The weight of the body is acting down towards the ground. We have the normal reaction R. Now, in this case, there are two constant forces that will be acting on this body initially. The first one is the force of pull, the pulling force, while the second one is the force capable of sliding this object down, which is what? Mg sine theta. Now remember, we are dealing with rough inclined plane, which means friction also must be included. But then we need to consider the position of friction. Now, when the body is about to move off the plane, there will be a force that will be opposing the motion of the plane, and that is what? Frictional force. Now, since the body is about to move upward, that is, the direction of the body is going this way, the opposing force will be going downward. So, in that case, we are going to have our frictional force acting parallel to the force capable of sliding it down. Remember, this is mg cos theta. Now, whenever you have a body placed on an inclined plane, there are two considerations we need to actually consider, and that is the vertical resultant of the forces and the horizontal resultant of the force. That is, whenever you want to consider the forces acting on the body placed on an inclined plane, the forces will be considered vertically and also horizontally. Now let's consider that based on that fact. Now, the vertical resultant will be considered by looking at the plane vertically upward. Now, if you look at this plane very well, you notice that the two forces that are acting vertically in this plane is normal reaction and the what? And the mg cos theta. Now, based on the principle of equilibrium, the net force at equilibrium is always equal to 0. On that note, trying to calculate the resultant of this force acting opposite direction, we are going to have r minus mg cos theta equals to 0. Since at equilibrium, the net force is equal to what? The sum of the net forces equals to what? Equals to 0. So you can transpose this. If you transpose that, you have r to be equals to what? Mg cos theta. Can you see that? So you can call this equation 1. At the same time, we need to consider the horizontal forces as well, acting on this same body. So horizontally, the horizontal consideration will be considered by considering 1, 2, 3 forces based on the sum of forces at equilibrium. Now, since these two are acting in the same direction, you add them, then this one acting in opposite direction to it will be subtracted from that. So we are going to have f plus mg sine theta minus p equals to 0. So if you transpose p, we are going to have f plus mg sine theta equals to what? P. So these are the two forces we need to actually consider. That is the resultant vertically and the resultant horizontal. So these two formulas are very, very important when solving problems on this kind of case. Don't forget, R represents the normal reaction. That is the upward force the plane is acting against the body. F is the frictional force. That is force that opposes motion. Mg sine theta is the force capable of sliding the object down the plane, while P is the pulling force. That is the force capable of moving the object of the plane. But then, you may ask, what is the formula for frictional force? Remember, according to Hamilton law of friction, that is Hamilton, Hamilton's Hamilton's law of friction, it is established that the frictional force is directly proportional to the normal reaction. That is, the more the normal reaction, the more the frictional force. Now, replacing this proportionality sign with another expression to form an equation, we are going to have F to be equals to coefficient of static friction or kinetic friction, which is your mu, times normal reaction. On that note, we can say that F equals to mu r. So if you replace mu r, like replace your frictional force with mu r, we're going to have what? Mu r plus mg sine theta equals to p. So these are the formulas we need to know when it comes to rough inclined plane when the body is about to move off the plane. Don't forget, I still remain your tutor, Professor Bajowo Daniel Nicole, also known as the Macroeconomic Arithmetic Biologist.